Okay, so let's start with another exercise of logistic regression. Now this exercise is for selection of candidates for admission. So before starting, let's clear the output first by clicking on this, and this will help us in clearing all the processes. Whatever output is there, all will be cleared. Now this, as I said, that the selection of candidates for admission, that is the problem, that is the objective of this particular exercise, and this is under logistic regression. So we are going to run this, nothing will happen. So in this exercise we have 40 candidates data, and we have to decide whether they got admission or not. There are three independent variables, that is GMAT, GPA score and years of work experience. The dependent variable represents whether the person gets admitted or not. So this again we can run. Then we are going to import the libraries, that is pandas, sklearn, linear model, matrix, seaborn and matplotlib. So we can run this so that we can work on our data. All these libraries are required so that our coding becomes easier. So that is the purpose of using these libraries, and these are very well supported in Python. That is why Python has become so powerful and so useful. So after importing all this, we will start working on our data set, right? So this process has been completed. Now we are also going to import the pandas, because now the data is available in this particular variable known as candidates, and the various array elements are GMAT, GPA, work experience and admitted, right? So you can see these are the scores, then this is GPA score, then work experiences and admitted. And then the data frame that we have is this, that is candidates columns, and then GMAT, GPA, work experience and admitted. So we can print this also. So after doing all this, we will get some output in the form of these details, that is GMAT, GPA, work experience and admitted. This is what we can we are going to use, right? So now we are going to transfer these four variables, that is GMAT, GPA, work experience, into this X, and the admitted into Y, because that is our result. So we can run this also, as we have run this. So once we run this, then we can transfer the details of the data into these X and Y. Now we are going to split the data by writing this particular code, that is xtrain xtest, ytrain ytest, and then train test split. This is the code which splits the total data set, and the test size is 0.25. That means 25% of the data is kept for the testing, and random state is 0. There is no iteration in this. So once we execute this particular code, the data will get splitted as per the ratio it is mentioned here. Now we are going to apply the logistic regression as follows. So logistic regression is equal to logistic regression. When we are transferring that, and then logistic regression is dot fit. We are going to fit that, because as we know, we have already splitted the data, and now we want to fit the model. So xtrain, ytrain. After training into this, then we are fitting it and putting it into logistic _regression. And now we are going to predict ypred, logistic regression, predict x test. So on the basis of this, then the data that we have trained, now we are going to predict, and that will be stored in the ypred. So we can run this, and it will get stored in this ypred. Now use this code below to get the confusion matrix. Now we are going to get the confusion matrix, which is again very useful in this. So confusion matrix is equal to PD cross tab ytest ypred, row names is equal to actual, and column names is equal to predicted. So this is clear that under row we will get the actual figure, and under column we will get the predicted one. So now sn.heatmap, we are going to create a heat map for this, for confusion matrix, and the annotation is going to be true. So once we use this code, then we are going to get a plot in the heat map, right? So you are getting this heat map, right? And this is also having the annotation, that is 4114, right? And this is a kind of a confusion matrix. Now, as we mentioned, that this is the actual and this is the predicted one, right? So that is how you can, like here, row names is actual and column names is predicted. So same thing is mentioned here. Then we are going to run the code in Python, and you will get the above confusion matrix with the accuracy of 0.8. Note that depending on your sklearn version, you may get a different accuracy results. Now this value 0.8, it may change, because the more you repeat it or iterate it, it may change, or maybe in different times you may have different values. So don't worry about that. This should be something close to that. It may not be exact this. So we can run it. Nothing will happen in this because it is all remark. So for the final part, print the accuracy and plot the confusion matrix. Now we are going to print the accuracy and also the confusion matrix. So the code for that is print accuracy matrix, accuracy score, y test, y pred, and then plt show. That means we are going to print the plot. So once we do that, we got the accuracy as pointed as mentioned here, and then we are going to it is already given this kind of a score. Now let's print the two components in the Python code, that is print x test and print y pred. So we can do that also with the help of this, because it is already available to us. So we can say that GMAT, GPA and work experience, with this kind of a, we have got the result as 0011001101. That means 0 means that it is admitted, and 1 means it is not admitted. So recall that our original data set and had 40 observation, and since we get the test side as 0.25, then confusion matrix displayed the result for 10, because we wanted to, out of 40 we wanted to test for only 10 points or 10 elements. So that is why we got the result for 10 points, right? And that is our 25%. So the confusion matrix displayed the results of 10 records, that is for 40 into 0.25, that is 10. And these 10 records, the prediction was also made for those 10 records, as 1 means admitted and 0 means rejected, right? So we can run this also, and this is only for our understanding. Then checking the prediction for a new set of data. Now we want to see that this is a model that we have created. Now we want to check that suppose some new candidates come in, so what would be the outcome of that, whether they will be admitted or not. So to check that, we are going to use the same model, and now we are going to check the prediction for them. So let's say that you have a new set of data with 5 new candidates. So we can run this. Of course, nothing is going to happen here. The goal is to use the existing logistic regression model to predict whether the new candidates will get admitted or not, right? So the new set of data can then be captured in a second data frame called df2. Now earlier we had df, now we have got the df2. So we can run this also. Of course, nothing is going to happen. Now new candidates is equal to GMAT, and this is their score. GPA is also this, work experience is this, and now df2 is PD data frame new candidates, columns GMAT, GPA were same, right? So this is our new additional set of data, and for which we want to predict, right? So we can run that, and now we are going to use the same model which we have got earlier for the purpose of checking. So checking the result. So y pred is equal to logistic regression predict and df2. Now we have used df2. Earlier we used df. Now we are using df2, and print df2 and print y pred. So we can run this also, and we get this as all these 5 new data set that we have got, new candidates, we have got this as the result, and the outcome of that is 01101. So on running the code, we'll get the above prediction. And so thus so we can say that the first and the fourth first and the fourth, right? 0, 0 here are not admitted because they are 0, while the other candidates are admitted. 1, 1, 1 they are admitted and 0, 0 are not admitted. That's how the model works. This completes our logistic regression. Thank you.